Okay.
Assalamualaikum and good day. So we are from UTM 1720 and we'll be showing our SDPS for Iskandar Putri low carbon monitoring system. So next, here is our team, which is my name is Muhammad Ben Azmi, and my groupmate is Muhammad Akmal bin Muhammad Nizam and Muhammad Rizfahan Rosli. Next, so here is the role and task given. Next, next. It's a table of contents for this SDS of our introduction. So the Iskandar Putri Low Carbon Initiative Community Monitoring System, as detailed in this software design document, serve as crucial roadmap for architects, developers, and stakeholder alike. Within this page, we are unravel the intricacies of the architecture and design, providing a comprehensive guide to empower the sustainability practice and contribute meaningful to the ambitious vision set forth by the Iskandar Putri City Council for low carbon future.
Okay, so next, we'll talk about the purpose. So the software design document SDD for Iskandar Putri Low Carbon Initiative Community Modeling System is a detailed guide that defines the system architecture, components, and interactions. It also specifies the design of each component, including its functions, data flow, and interface, while also establishing clear communication links between system elements and addressing non-functional requirements like performance and security. This document serves as a roadmap for development teams, project managers, and stakeholders, providing insights into the system design and facilitating future maintenance and enhancements. Next, we move on to scope, where the initiative by the Iskandar City and BNB, where this system will collect and analyze data related to energy, water waste, and recycling to help users, including residents and MBRB staff, monitor their carbon footprint. We generate reports and a dashboard for users to track progress and reduce their environmental impact. Importantly, the system doesn't enforce specific carbon reduction sections but serves as a tool for promoting sustainability. It aligns with the goal of the Iskandar Putri Low Carbon Blueprint of 2025. So the software will follow higher level specifications and project objectives. So next we move on to context, where this is a standard guide for the people involved in creating and using the software, SDD, software development. It focuses on improving the quality of design information and offers effective in SSDDs. It meant for both designers and those who use SDD, ensuring that design descriptions are complete, clear, and consistent. This standard also helps organizations improve communication, consistency, and overall quality of their software design document. Now we move on to the summary, where it starts by outlining the project goals, and then it goes into the detail about the architecture, explaining the structure and how component relates. The document also clarifies that why certain design decisions were made and covers aspects like data management, phases, and system behavior. It's structured for easy reference, helping stakeholders understand the design and make informed decisions during software development. Right. So next is
So for zero, design body, 5.1 is stakeholder and their concern. So in the analysis, we dive into the diverse perspective and priorities of key stakeholder, the design of Iskandar Low Carbon Initiative Community Monitoring System (IPRK). So we have a user, including the resident, institution, and NBIP division, prioritize aspects like usability, interface design, overall experience, focusing on seamless interaction with energy consumption, water, waste management, recycle. And another user is an administrator, which emphasize on system security and control to safeguard their integrity and confidential of collected information. Next, in the context of viewpoint, the design concern, the IPRK is instrumental in elucidating the service provided by the system within the specific context. Users stakeholder, including resident, institution, MVIP division, and regulator authority, play vital roles in shaping and interacting with the IPRK CMS, contributing to its overall framework, establishing the system boundary amount, delineating the limits within which IPRK CMS operate and interacts. Next.
So next is we talk about the use case diagram, where the use case scenario, we have 8 use case. We start with UC001, which is register. For registration, it's a normal registration system where the user navigates to the registration page. The user select the register option. The system displays register form. The user enter the required information. The system validates the entered data, and if the data is valid, the system registers the user. When they confirm, it will display a successful registration. So the post condition, the user account is created in system and user receive confirmation message. And we have alternative flow 2, if the entity username already exists and the system prompts to choose different one. So the same like as a normal user system. And next we move on to UC002, which is a use case for login. For login, the actors are user and admin. So this one is the user navigates the login page where they enter the username and password. The system will validate, and if the system valid, the system will make sure that the user or admin will log in, and the system direct to the main dashboard or the home page. So the post condition is the user is successful onto the system, access granted to use personalized content. So if the user enter incorrect, we will go to the login page again to repeat the process. Uh, if the user repeat to 5 times, credentials are entered are cancelled. So they also have a anti-flow tool if you forgot the password. So next is for C003, we have access for the user where we have preconditions where the user is on the login page of system to make sure that user must be logged in first. So first for the event is just go to the homepage. We can select the water consumption form. The user will enter the submit water consumption form of their data, the usage, where they submit their bill, and then the system will validate the entered data to ensure accuracy and completeness. Once the data is valid, the system will be recorded into the system and confirmation will be sent to the user. So the water bill data will be stored inside the database. User confirmation, user will receive a confirmation message, and then if the correct credentials will be entered, water bill data will be prompt user to enter the correct data, and it will repeat until the data is ready. So if there's an error during the login process, the system display an error message and prompts the user to try again later. For UC003, UC04, and UC005, all of the, and UC06, all of the form is of the usage of the system is going to be similar, but they enter their carbon details of the data, and the steps are almost identical. So let's move on to UC007. For UC007, we have an admin as an actor. So this admin is a use case scenario where the system will calculate the carbon usage based on the user's carbon data that was being entered by the user. So when the user enter data, the admin navigates to the calculate carbon emission section within this kind of trivial carbon. The system provide interface for the admin to select the user data, which carbon emission need to be calculated. And the admin select the relevant data source, example, electric consumption, water consumption, transpiration, data on this data. And the system retrieve the data, retrieve the selected user from the database. The admin configures the carbon calculation parameters, and the system perform the carbon emission calculation based on the selected data parameters. And the calculated carbon emission data is displayed to the admin page. And then the admin page has the option to download or export the calculated carbon emissions for data for further analysis or reporting. So the post condition is where the carbon emission data is created and made available to the selected user data. Admin has access to the calculated carbon emissions data for analysis and reporting. So active flow one, we have if they do no data is selected, the if the admin attempts to calculate carbon emission without containing user data, the system prompts the admin to choose at least one data source. The admin selects the relevant data source before proceeding. Exception flow, we have a system error during the calculation of the carbon system. Lastly, we have a use case for generating the report. This one is for the access of admin, where we have preconditions. It must pass the UC007 first. So in UC008, the fraud event is the admin navigates to generate carbon emissions report session within this Kadaputri low carbon monitoring system. And the system provides an interface for the admin to specify the criteria for the report. And then the admin configures the report parameters based on desired scope content, where the system retrieves the relevant calculated carbon emissions data from the database based on the specified parameters. And then the admin reviews on the preview of the report to ensure it includes the necessary information. And then the system generates the final carbon emissions report in the readable format. And the admin has the option to download or share the generated report. So first condition is a comprehensive carbon emissions report generated based on the specified parameter. So that's it for the use case. Move on to the next one.
Okay, so for the composition viewpoint, we have we will be using MVC, model view controller. We choose the MVC because the constructing the MVP website, it fits well with the requirement of web development. Furthermore, the MVC idea really fit with Java because we use it for the backend in this architecture. Model represent the characteristic of the capability of object like the user class that holds data such as name, address, and their details. The view is representing the interface or output visible to the users after the system process. It's a display the static or the forms. And lastly, the controller, which is responsible for processing data from the model and translating it to the UI, user interface. For instance, when user interact with certain button on the website, the web page accordingly setting to the specific condition or navigating to the other page. Next, 5.4 logical view. For the logical view, the IPRK focus on elaborating the implementation of class and their relationship, providing insight into the internal structure of the system. Next is the below is as you can see, this is the class diagram. We have the user and staff where it takes the data from user. Staff can do a report, and the form and user is a associate, and the water form, electric form, transportation form, and recycle form is inherited from form, and each of them has their own attribute. Next is the informative viewpoint. Here we have the entity and the description. For the user is the represent the anyone who interact with IPRK. The staff represent the IPRK staff. The form is the entity that to contain the form ID, UID, month, year, and the data that user submit. Water, electric, recycle, and transportation form is the entity that inherit the form entity. And lastly, have report, which is the entity to generate report based on the user data. Next is the ERD, data dictionary. Next. So we have an entity user. The user have attribute UID, username, password, address, phone, which most have string 50 and string 255 for address and integer for phone. The staff inherit the user attribute. Also have extra, which is staff ID for unique staff ID to access the admin homepage. Next is the form, which is got contain form ID, UID, month and year. The entity for water, electric form, and recycle, the transportation, inherit the form attribute with their own attribute. For example, water have a consumption, electric form has a usage, recycle has a quantity, transportation got the fuel type and distance. And next, the ERD is the ERD for the below. Next, here is the ERD. So we have a user, staff, report, form, water form, elective form, transportation form, and recycle form. Next.
So for the interface viewpoint, the viewpoint is a comprehensive guide that illuminates the user experience and system functionality within the MBIP. It delves into the user perspective by detailing the intricacies of the login and authentication processes, elucidating the layout and content of the user dashboard, and providing specific insights into each major feature of the system. The viewpoint also meticulously outlines feedback mechanism, including notification and error message to enhance user clarity and engagement. So for the structure viewpoint, the design concern, the
Yeah.
primary objective of the structure viewpoint is to detail the organization and interrelationship of the various packages within the MBIP system. This viewpoint focuses on ensuring that the system's architecture is scalable, maintainable, and facilitate easy integration and separation of concern. So what the concern is modularity, cohesion and coupling, scalability, extendability, data integrity and security, and lastly user interface consistency. So for the package diagram, this is our package diagram. We have 6 packages, which stands from user services, validation services, admin services, database, UI services, and system error handling. Then next we move on to the interaction viewpoint, the sequence diagram. Akmal.
Alright. Let's move on to the sequence diagram. Can you show me the sequence diagram? Alright. For the sequence diagram, here we have a sequence diagram for the sign up of the user, IPRK system, and database. So this is a normal sign up sequence diagram. Nothing special inside here. So let's move on to the next sequence diagram. Sequence diagram 2 is for login scenario where this validates the user. If the user is not valid, that will return to the home page. This is a simple login scenario. The next. So next we have a water consumption form. So in this, in all this form, the user will enter the data, and then after user enter data, the system will validate the data, and then the system will store the data. And the system is stored, it will check whether the data is valid or unvalid. So it will do a loop on the data. If the data is not valid, it will do the looping until the data is valid. So then we have done for the SD003. Let's move on. For SD004, it's the same concept for like a form for SD003. So let's move on to SD007. Since most of the form is the same, it's going to be the same thing. So move on to SD007, where we also have an admin where you have an admin calculate cover system on the database. So admin will log in, and when they log in, it will display the login page, sorry, the home page. Then admin will select data source, and the system will retrieve the data source, and the database will return the user data. And then when admin select the data source, it will configure the parameter, perform calculation, get calculated data, and then the database will go back and send the data to the calculate cover system and then to the admin. So once the system done, admin can download the calculated data and export the calculated data. So next. Now for the sequence diagram, we have a place where generate report, we have admin, PRK system, generate report and database. The admin will select, we click the report and we specify the report, and we retrieve the calculation data from the database. The database will return the calculated data. The generated report will copy the report and generate final report, and the system will provide the generated report to the admin, and the admin can download the report by clicking the system. So if there's no data in for the specified parameters, the system will ask the admin to choose other data. Other than that, the system will display error. Next.
Okay, for the state dynamic viewpoint 5.9, regarding the design consideration, a specialized perspective is adopted for reactive systems, and those were internal actions and are of primary importance. This viewpoint focuses on the system's dynamic, including modes, states, transition, and response to a specific event. The main goal is to depict the system's dynamic nature. A state transition is an effective tool for this purpose. It provides a clear depiction of the system's various possible states, the transition between these states, and how the system responds to different events. And this dynamic perspective is essential for guiding designers, developers, and testers in understanding how the system evolves over time. Designers use it to comprehend the system of workflow, developers utilize it to craft efficient state transition handling, and testers rely on it for creating thorough test scenarios to ensure the system's functionality in various situations. So for the state diagram, we have three state diagram, each for each use case subsystem. So first we have the state machine diagram for class register. As you can see, it starts with the registration page, and then it show all the states until the confirmation message. And then next we have the state machine diagram for login. So we start with the login page and then finishes at the credential validation and then end up to redirect to dashboards. Then next we have the state diagram for the water form. So first the user log in to the system, navigate to the water section, submit their data, and then it will display their water bill. And then lastly it will record the water bill info into the database and then display the confirmation message. And then for the next recycle form, electrical form, and the transportation is all similar processes and states. So next is the pattern design, which we will explain what design pattern we chose to extend the class diagram. So for this system, we chose to extend two class diagram, which is the water form and the report generation. So for the water form, we chose to use the observer pattern. So the reason we choose the observer pattern for extending the water form class in our project for several compelling reasons. These patterns, which establish one-to-many dependency between objects, align perfectly with the dynamic nature of our application. Firstly, the pattern's dynamic update mechanism is a major advantage in our water form. Whenever the state changes, it is crucial that various parts of the application are notified and updated instantly. The observer pattern makes this possible by automatically informing all observers of any state changes. This is particularly useful for real-time data requirement like those in our application dashboard. And another critical factor is for decoupling. It provides by using this pattern, the water form class, the subject, stays loosely coupled with its observers. This means we can add or remove observers without needing to alter the water form class. And as a student, we find this aspect particularly appealing for its potential to simplify the development process and enhance the system's adaptability to changes. Scalability and flexibility are also major consideration. As the application grows, we can effortlessly integrate new types of observer that need to keep track of the water forms stage changes. This scalability is essential for our project, which is expected to evolve and expand over time. From a maintenance and reusability standpoint, the observer pattern is a game changer. It promotes a design where the concerns of different components are separated, and this separation enhances the maintainability as changes in one part of the system, like the water form, minimally impact other parts. The observers, moreover, the reusable nature of the observers across different subjects can be significant time saver. So next is the general report. So we decided to extend this class using the composite pattern. So the reason is the hierarchical representation. Our project involves handling various forms like water form, electrical form, transportation form, and recycle form. These forms can exist independently or in a combination. The composite design pattern is a perfect for this scenario as it excels in representing part whole hierarchies in a tree-like structure. This approach mirrors the real-world structure of the forms in my project. So uniformity in object treatment, a key advantage of the composite pattern is its ability to uniformly treat both individually objects and their compositions. This means in my generate report functionality, whether I'm dealing with a single form or a composite or multiple form, the process remains consistent. This uniformity simplifies the implementation and make the codes more intuitive. And then next, we have the simplification of client interaction, enhanced flexibility and scalability, and lastly, promotes reusability. In essence, the composite design pattern aligns perfectly with the requirement of our project, providing a robust framework for managing forms in a hierarchical structure. This not only make our general report use case more efficient, but also ensure the system is scalable and easy to maintain. So next, chapter
So
7.
next, move on to user interface design. So I'll simplify this in a short form. So our system, the low carbon model system, has a user-friendly interface designed to guide users and administrators smoothly through various tasks. It starts with easy registration where users enter their details and the UI checks for accuracy. After successful registration, users are directed to their personalized dashboards. For login, users enter their credentials and the system grants access to or helps with password recovery. Data submissions form like water consumption and others follow the same user-friendly approach with the validation checks. So administrators use the UI for tasks like calculate carbon and generate carbon emissions report. So with options for data selection and report generation, this system ensures a seamless experience, making carbon monitoring and management efficient for all users. So next, we take a look at the user UI, discrete images. So this is for the registration page, very simple. The login page, we have home page admin, document submission validation user, carbon footprint calculation, and generate report for carbon emission. Okay, next we move on to traceability metrics, where the sequence diagram for each use case with corresponding classes are as below. So here are the traceability metrics. We have user, admin, manage, and report controller. So that's it.
So here we have a login page, basically email and password. So register, you click on the register link. Here we have the register page. For example, I put farhad@gmail.com. Farhad address is Kuala Lumpur. Password. If I click register, if it valid, the page. So if I go to the page here, I click login. Here is the login page for user page, which is not completed yet. But here we have the for UID and name. So if we press the logout, we will go to the login page with no session. Dah.
Okay, so for the prototype of water form, so this is the water form where the user need to enter their household water usage and outdoor water usage. So for example, it's 1000 milliliter, 122. The next, then they will redirect it to the home page. Then the database will be inserted in the water table. Then for the codes, since it is using the observer pattern, so here is the form water form controller where it has the get mapping and all of that. So when the user submitted, it will check the final submission, then it will update the session tracking, and then update the database to redirect to the home page. And then this is the form servlet, and then there's a observer where it will update the database water usage, and then it has the session tracking, which will constantly update the session if the user submitted or filled the water form. And then this is the summary report generator, which implements the observer form. So that's it for the water form observer pattern.